We come across automobiles every day, but what is the working principle of its engine? Is it the same for the scooter of a grandpa's time or the motorcycle that you drive? Welcome to Gauge How. I'm Samriddhi Agarwal, and in this video we will find the answers to these questions. But before we dive into the topic, check out our other videos about IC engines and its types. In 4-stroke engines, there are two types: spark ignition and compression ignition engines. The working principle of the two is similar, but with some fundamental differences. We will discuss each one by one. The first is 4-stroke spark ignition engine. In this engine, the cycle is completed in 4 strokes of the piston. When the piston completes 4 strokes, the crankshaft makes 2 revolutions. Each stroke consists of 180 degrees of crankshaft rotation, thus it requires 720 degrees of crankshaft rotation to complete the cycle. Since ignition in this engine is due to spark, thus it is called spark ignition engine. Compression ratio for this engine is between 6 to 10. Compression ratio is the ratio of the maximum to the minimum volume of the space draped by the piston of an IC engine during a comply stroke. The ideal 4 strokes are suction or intake stroke, compression stroke, power stroke, and exhaust stroke. In the first stroke, that is suction stroke, the piston moves from the top dead center to the bottom dead center. As the inlet valve opens, the piston is about to move downward. The inlet valve motion is controlled by the crankshaft. Due to the piston movement, partial vacuum is created inside the cylinder and fuel-air mixture is injected inside. Exhaust valve is closed throughout the suction stroke. When the piston reaches the bottom dead center, the inlet valve closes and hence suction stroke gets completed. During the compression stroke, the piston moves from bottom dead center to top dead center. The charge injected in the previous stroke is compressed by return stroke of the piston. Both inlet and exhaust valve remain closed. At the end of the stroke, the charge is ignited using a spark plug and the combustion takes place at constant pressure. We make use of the carburetor and ignition system. Carburetor is a mechanical component that mixes air and fuel for SI engines in the proper air-fuel ratio for combustion purposes. The third stroke, that is power stroke, is also known as the expansion stroke. The whole magic of power generation occurs in this stroke. Both the valves remain closed. The heat released from the combustion process increases the pressure, which creates a thrust that pushes down the piston to bottom dead center and creates power output. Power is produced in this stroke only. The downward motion of the piston provides positive driving power. The fourth and final stroke is exhaust stroke, in which the exhaust valve is opened when the piston moves upward from the bottom dead center. Piston pushes out burnt and residue gases to the atmosphere through the exhaust valve. This process is known as scavenging. The engine repeats this whole cycle again. The next type is 4-stroke compression ignition engine. The working principle of this engine is quite similar to the SI engine, but with higher compression ratio, which is between 16 to 20. In this engine, only air is inducted instead of air-fuel mixture. We make use of a fuel injector and high-pressure fuel pump for injection of fuel. In the suction stroke, the pressure difference generates as the piston movement pulls the molecules of the air inside the cylinder. During this stroke, the inlet valve is open and the exhaust is closed. In the second stroke, that is compression stroke, both valves remain closed. This isolates the combustion chamber from the atmosphere. Pressure and temperature are raised due to compression. Thus, it has a high compression ratio. At the end of the stroke, the fuel injector injects the fuel in its atomized form and compression helps the air to achieve its self-ignition temperature. After achieving the self-ignition temperature, in the power stroke, the air turns hot and the atomized fuel molecules absorb the heat from the surroundings. This leads the fuel molecules to vaporize, which results in combustion and a large amount of energy is generated. After the fuel injection is complete, the product starts expanding. Both the valves remain closed during this stroke. During the last stroke, which is exhaust stroke, the inlet valve is closed and the exhaust valve opens. The residual gases after combustion, like unburnt particles and harmful pollutants, are disposed out of the cylinder through exhaust valve. The movement of the piston from bottom dead center to top dead center pushes out the combustion product and the whole cycle is repeated. It is like cleaning your house before the guests arrive, except the charge is the guest and engine is the house. Also, it visits really frequent. The other type is two-stroke engine. On contrast of the four-stroke engine, a two-stroke engine completes a power cycle with two strokes of the piston and crankshaft makes only one revolution. The compression and power stroke of the four-stroke cycle is carried out in this engine without the suction and exhaust strokes. One stroke is for compressing the fresh charge and the other for expansion or power. Hence, two strokes are sufficient. The number of moving parts is less in this engine as compared to four-stroke, and we have ports instead of valves. Generally, there are three ports, that is, inlet port, exhaust port, and transfer port. As the name suggests, the inlet port allows the charge into the crankcase. It is placed in the bottom side of the crankcase. Conversely, the exhaust port discharges the burnt and residue gases out of the combustion chamber. Transfer port is used for transferring the charge from the crankcase to cylinder head portion. The two strokes in this engine are compression and power stroke. In the compression stroke, the spring-loaded inlet port opens and the air-fuel mixture enters the crankcase and the piston moves upwards, compressing the mixture. Due to the pressure and temperature change while compression, gases get heated up. Next, in the power stroke, the heated gas exerts high pressure on the piston and the piston moves downward. Waste and residue gas are scavenged. Some other types of two-stroke engine exist in which instead of using the crankcase and piston's upper side as the fresh charge pump, we are using a separate rotatory blower which is directly connected to the transfer ports. Exhaust valve is absent in this. These are widely used in marine and rail engines. Two-stroke diesels are inducted with pure air, not an air-fuel mixture. Their fuel is injected only after all ports have closed. This would prevent any sort of loss. That is all for this video. I hope you liked it. Like and share this video, and for more videos like this, subscribe to this channel and click the bell icon. Also, check out our other videos. Thank you for watching.